want to look at this rational expression and simplify this. Once again, what we're going to try and do is see if there's any factors anywhere involved. And if I look at the numerator, it appears that there's an x squared that is common to both the two terms on the numerator. So I'm going to factor an x squared out. Continue writing the entire equation, entire statement, just so I can kind of carry some commonality all the way through. Now if I look at this, I can see that there is a common factor of both the top and the bottom, or a clever version of 1. I have an x plus a 1 over an x plus a 1. Therefore, I can cancel both of those guys out, and I'm left with an x squared. So this expression has been reduced just down to x squared. However, you might be asking yourself, well, wait a minute there, Willie. Didn't we just talk about at some point that I have to be careful about which numbers I can use or which ones I can't use? Didn't you say something about the denominator can't be 0 or the entire expression crashes? Well, that's correct. So I have to look at my simplification here, x squared. Well, this is true. That's the true simplification of this rational expression for all values of x except for where it crashes. And it crashes here when x plus 1, that whole thing becomes 0. And that occurs when x is negative 1. So my end solution, my end simplification of x squared, that's true in every case except for where x does not equal negative 1. And that's just something that's kind of good to keep an eye out. As I go through and look at some of these problems and figuring out how to reduce them, I have to be careful of when does that denominator become 0.